Hey guys, today I'll be making a 2-axis brushless handheld GoPro gimbal that you can make yourself for less than $75. So join me if you want to make your own. The main components are some half-inch PVC, two 9-volt batteries, a 12-volt linear regulator, and a UAV gimbal that you can buy off of eBay for less than 55 bucks. Always start by prototyping your circuits on a breadboard. I use a multimeter to make sure I'm getting the right output voltage and I won't bust up my gimbal. I'm using an ML7812 voltage regulator from Radio Shack that only cost me $2 and will work perfect for this circuit. Once I know it's working, I'm going to build a circuit permanently on some perf board. You can cut perf board just by scoring it with a razor blade and snapping it apart. I gauged roughly the size I need by putting down all my components and giving them ample room for wiring and whatever I want to put on the board. Now I just need to solder in the components. This will consist of 2 output headers for the gimbal, 4 input headers for the 2 different batteries, and of course the 12-volt linear regulator. Right now I'm bending over some header pins so I can insert them into the circuit board. Sometimes I also add a dab of hot glue so that they stay firmly while I solder. It's also not a bad idea to label your inputs and outputs. All the wire is going in on the underside and will be soldered in. I made a mistake, so now I need to cross the red wire, which is my positive, over the negative wire. Now I'm soldering in the leads of my battery clips to some headers so that I can easily connect them in and out of the circuit board. This will make the whole thing really modular and easy to take apart. I'm reinforcing and sealing the joint with some heat shrink tubing. I quickly test the finished circuit with a multimeter, and now I'm going to plug it into the gimbal to make sure that both of them work together well. The gimbal looks like it's coming alive and it's working, so we're going to move on to the next step. Once I'm 100% sure that the circuit is working, I'm going to hit everything with a layer of hot glue. This is going to protect all the joints and keep them from breaking apart. But only do this if you know that your circuit is 100% functional. Right now I'm mapping out the PVC handle so I can get a feel of what it's going to be like. Once I decide upon a good geometry, I'm going to measure it and go down and cut it. I ended up just holding the PVC in order to gauge how long I wanted the handles to be. Most saws can cut PVC, but make sure you do it in a well-ventilated area or outside, because it can create some nasty plastic dust. I'm doing it in my basement. I'm pretty much eyeballing how long I want this to be on the spot. Now that I have all the pieces together and I'm back upstairs, I can throw it all together. All the pieces snap together just fine, but if you really want a strong joint, you can use some sort of glue, but PVC glue isn't really 100% necessary here because we don't need it to be waterproof or super strong. I need to figure out a way to attach this 3/4 inch elbow onto my gimbal head. I'm taking a couple measurements so I can go into a CAD program and design and 3D print something. After doing some thinking, I decided I was just going to make a coupling with a base plate that can screw onto the gimbal base. I'm using Google SketchUp here because it's really easy and fast. I recommend that all of you learn it. In order to screw the base plate onto the gimbal, I'm just using some perpendicular screw holes because those will be able to go into the perpendicular slots on the gimbal base. I'm printing this with my rep wrap with PLA. I'm doing 100% infill and it's only going to take about 15 minutes. The first layer is always the slowest. Now that it's done, I'm just going to use some CA glue to attach the two. Make sure you line it up right the first time because you only get one shot. I messed it up and now I can't fix it, but it's only off by a little bit, so I'm totally fine. The CA glue is definitely strong enough for what we need. I know that most people don't have a 3D printer, and if you don't, you can just use some 2-part epoxy to attach the 90-degree elbow to the plate of the gimbal. I'm using 2 diagonal M3 bolts to connect the 2 mounting plates together. Now I just have to connect the mounting plate to the gimbal with the anti-vibration pads. I temporarily attach the components to the handle with some zip ties. This doesn't look so nice, but for now it'll do. Since I accidentally got a 3/4 inch elbow instead of a 1/2 inch, I'm going to have to use a set screw in order to secure it in place. PVC is super easy to drill into as well as screw into. Right now I'm drilling the pilot hole, and then I will drive the screw in by hand. It feels secure. Now I plug the pipe back in and I'm all done. It looks like it's working perfectly right now, and I'm really happy with the result. There are some companies offering pretty much the exact same thing for over $200. Making this for less than $75 is the perfect example of why being a maker is awesome. Anyone, even with the basic tools and skills, can make one of these for their own. Personally, I'm really excited about using it to do some awesome mountain biking videos in the future. Let's go outside and put it to the test. I'm going to start by walking up and down the stairs with the gimbal in my hand. So far, it's looking pretty smooth. Now let's see what it's like when I run up the steps. I took this footage without the gimbal, just by holding the GoPro in my right hand. I think this really worked out well. Please like and subscribe for more videos like this, and I hope you guys go out and make one of these of your own. Send me some pictures, show me what you guys did, and tell me if you have any suggestions.